Dr. Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to DTH channel, lecture 7 of Astronomy and Astrophysics. This lecture is about Sun, our nearest star. We have to know more things about Sun, how energy is produced in Sun, what is the structure of Sun. All these things can be learnt from this lecture. I am going to organize this lecture in the following way: introduction, properties of Sun and structure of Sun, energy production in the Sun, summary of the discussion. Sun keeps our planet warm enough for living things to thrive. It gives us light so we can see. If there is no Sun, just imagine our life, how difficult it will be. Life will not exist if there is no Sun. The Sun sends lots of energy towards us, light energy, heat energy. In light energy itself, different types are there. Infrared radiation, which is a complete heat radiated out by the Sun. Then visible light falls in the wavelength region 4000 angstroms to 7000 angstrom is given by our Sun, so that this visible light falls on the object present in Earth, and all objects are visible to our eye, human eye. So all the objects except Sun are all a reflecting object. Only Sun is the natural object which emits light. Moon also reflects the light of Sun, so that it appears bright in night. In daytime it is not like a luminous body. So such a beauty thing is our Sun. There is also ultraviolet rays will come from Sun. You know, these ultraviolet rays will kill the germs and bacteria. At the same time, overexposure to these ultraviolet rays can cause burn to our skin, burn to all the living organism. So ultraviolet ray is emitted by Sun is very feeble. Feeble amount of ultraviolet rays are emitted by Sun. So Sun is a nearest star to us, which gives life to our planet, the Earth. Look at the picture of structure of the Sun. In this structure, you can see different parts of the Sun. Convective zone, which takes the energy produced at the core to the atmosphere of the Sun. Then the corona, the outer part of the Sun, which can be seen only when eclipses taking place in Earth. During solar eclipse only we can visibly see this corona part of the Sun, outermost layer of the atmosphere of the Sun. This is the core of the Sun, which is the only part which produces energy. Radiative zone, energy produced in the core is radiated to the atmosphere. Then streamers, coronal streamers, chromosphere. So like that, Sun is dissected into different parts by the solar scientist. This is the Parker solar probe which probes the Sun closely. So the properties of Sun known to humankind are due to this Parker solar probe. other probes also sent by different space agencies from the world to probe the properties of Sun. Coming to the actual basic properties of Sun, its mass is about 2.0 into 10 power 33 gram. Then its radius is about 7 into 10 power 5 kilometer. Density of Sun is 1.4 gram per centimeter cube. So it's nearly density of the water. So Sun central part or the whole Sun is in liquid form. It's not in a solid form as we think. Then the Sun is mostly composed of gases. Out of that gases, hydrogen exists with 94% by the number of atoms, then some helium 6% by number of atoms, and only 0.1% other elements are present in the Sun. So Sun is composed mostly of hydrogen 94%, helium 6% and other elements 0.1%. Coming to the effective temperature of the Sun, effective temperature in the sense temperature exists in the outer part of the Sun is 5762 Kelvin is the effective temperature of the Sun. Then the solar luminosity of Sun is 3.8 into 10 power 33 ergs per second. Such bright star we have in our solar system. So these are all some of the basic properties of Sun. Coming to the structure of Sun, as I shown earlier in this photograph, Sun has a central core which is the energy producing part in the Sun. Its radius is about 10% of the full solar radius. So if the Sun is about 100, for example, if you consider Sun as a 100 centimeter diameter ball, in that 100 centimeter diameter, 10 centimeter ball constitute the core of the Sun. The remaining parts are outermost layers or other parts. So parts other than this core are atmosphere. Outermost layers of the Sun form the atmosphere. We divide the atmosphere of the Sun into three parts. Photosphere. Most of the light we see comes from this photosphere, the bottom layer of the atmosphere of the Sun. So this is another structure of Sun. You can see the white around the Sun is coronal streamer. As I told earlier, we can see this only during eclipse, solar eclipse. This is the core, radiative zone, convective zone, which takes heat from the core to the outer surface, chromosphere, then Sun dark spots, then granular things, photosphere. There is another thing. So I told Sun atmosphere is divided into three parts. One is photosphere, then next one is chromosphere. This chromosphere is above the photosphere. This chromosphere is named because it is the source of red light seen briefly during solar eclipses of the Sun. During solar eclipse, we can see a small amount of reddish light emanating from the Sun. This region is called as chromosphere. This chromosphere is about 10 power 4 kilometer thick. Apart from this chromosphere, the outermost layer exists. This outermost layer is the corona of the Sun, which extends far into the space. This corona is very faint and for most of us can only be seen during total solar eclipses. This corona part of the Sun can be seen only during the total solar eclipse of the Sun. Beyond the corona, we have the solar wind. This solar wind not strictly part of the Sun, but a stream of particles from the Sun which emanates into the interplanetary space. So in our solar system, Sun exist as one of the light and heat producing agent. That light and heat is produced and radiated to Earth by these parts. The photosphere, chromosphere, corona. So these are the three layers of the atmosphere of the sun. Coming to the photosphere, most of the visible photon, visible photon in physics will lie within the wavelength range of 4000 angstroms to 7000 angstroms, or 400 nanometer to 700 nanometer. So most of the visible photon we receive from the sun originated from this photosphere. The photosphere of the sun is like the crust of the earth in some ways. Crust means it's the outer part of any object. Both the photosphere and the crust are many miles thick. Earth can also be divided into parts like core, crust, mantle, like that. Earth is classified? No. In that way, this photosphere of the sun is compared with the crust of the earth. The top of the crust is the surface of the earth. We are all living on the surface of the earth. So this surface is top of the crust. If we could stand on the moon and look at the earth, we could see its surface, earth's surface, its crust. So like that, if we look at the sun, we see the photosphere. We are not seeing the core of the sun. We are not seeing the corona of the sun. We are not seeing the chromosphere of the sun. So photosphere of the sun is like the crust of the earth in some ways. This is the photograph of photosphere, reddish. So this is how sun appears to us during set and rise time. The reason for this red color is the light from sun travels longer distance through the atmosphere during rise and set, and gases present in our atmosphere, Earth's atmosphere, diffract the light waves to appear as red color. The surface of the sun, like the surface of a boiling pot, is constantly changing. Photosphere is constantly changing. When we talk about solar granulation, we mean the cell structure or bubbly look of the photosphere. In that granular, you could see the bubbly look in the photosphere of the sun. Here, that granulars can be imagined as domains. In that domain, atoms will be there, hydrogen, helium. As I told earlier, hydrogen are the more prominent atoms in sun. Those atoms are the reason for the generation of energy, production of energy in sun. So that production takes place in the core part. The produced energy comes out from core to the corona through this granulation, cell structure. The boiling nature of the sun allows heat from the core to be brought up through the convection zone and into the photosphere, just like heat from the bottom of a pan ends up heating the entire content which we experience in our day-to-day life. So this is how the photosphere contributes for the sun. You can see the images of the granular parts of the photosphere of the sun. So this is the region where heat can be radiated to the corona part. Coming to the chromosphere, the next part, next layer in sun. This chromosphere emits a reddish glow as superheated hydrogen burns off. Hydrogen combines together and produces helium. Then that helium combines together and changes into another atom. This is the combination sequence in sun to produce energy. So the chromosphere emits a reddish glow as superheated hydrogen burns up, but the red rim can only be seen during a total solar eclipse. At other times, light from the chromosphere is usually too weak to be seen against the brighter photosphere. The chromosphere may play a role in conducting heat from the interior of the sun to its outermost layer, the corona. We see certain kinds of solar seismic waves channeling upwards into the lower atmosphere called the chromosphere, and from there into the corona. So this chromosphere acts as an agent to carry the heat from the core part to the corona part. So this is the picture of the chromosphere taken by solar probing satellite. Next part in sun is corona. This is sun is surrounded by a jacket of gases called an atmosphere. The corona is the outermost part of the sun's atmosphere. Corona is usually hidden by the bright light of sun's surface. That makes it difficult to see without using special instruments. So the corona can be seen during a total solar eclipse. During a total solar eclipse, the moon passes between the earth and the sun, so that moon's image fully fall on the sun, so that you can see the corona. This is the total solar eclipse image. So you could see a white region around the black sunspot. This white region is the corona of the sun, the outermost layer of the sun. When this happens, during total solar eclipse, the moon passes between earth and the sun. No. So when this happens, the moon blocks out the bright light of the sun. So the glowing white corona can then be seen surrounding the eclipsed sun. The corona reaches extremely high temperatures. However, the corona is very dim. The reason is corona is about 10 million times less dense than the sun's surface. This low density makes the corona much less bright than the surface of the sun. The corona's high temperatures are a bit of mystery, because the less brightness cannot be given for high temperature. So this mystery of corona is still unresolved. Imagine that you are sitting next to a campfire. It's nice and warm when you sit closer to the campfire, but when you walk away from the campfire, you feel cooler. This is the opposite of what seems to happen on the sun. Astronomers have been trying to solve this mystery for a long time. Still, it's not solved. The corona is in the outer layer of the sun's atmosphere, far from its surface. Yet the corona is 100 times hotter than the sun's surface. This is the mystery of the corona, still unresolved. A NASA mission called IRIS may have provided one possible answer. That mission discovered packets of very hot materials called heat bombs that travel from the sun into the corona. In the corona, the heat bombs explode and release their energy as heat, so that corona is hotter than the core part of the sun. But astronomers think that this is only one of many ways in which the corona is heated. So many other ways may be there for the corona to get the temperature, high temperature it possesses. The surface of the sun is covered in magnetic fields. This is the force that makes magnets stick to metal, like the door of your refrigerator. The sun's magnetic fields affect charged particles in the corona to form beautiful features. These beautiful features include streamers, loops, and plumes are all the thing about corona. Then we can view these features in detail with special telescopes. The corona extends far into space. From it comes the solar wind that travels through our solar system. The corona's temperature, outermost part of the sun's temperature, causes its particles to move at very high speeds. These high speeds are so high that the particles can escape the sun's gravity. So that is the mystery of corona still unresolved. This is the image of corona taken by NASA's Solar Dynamics Observatory, showing features created by magnetic fields, corona part of the sun. Here you can see the coronal loops, outermost part of the sun, coronal loops where the magnetic fields can be justified. Energy production in sun. So next part about sun is energy production. We know that energy is produced in the core of the sun. The size of the core is just 10% of the size of the sun. In that 10% of the size of the sun, this high temperature is produced and taken to the surface of the sun. The core of the sun is the region that extends from the center to about 20 to 25% of the solar radius. It is here where the energy is produced by hydrogen atoms. These hydrogen atoms are being converted into molecule of helium. You know, hydrogen has only one electron, helium has two electrons. This conversion of hydrogen into helium is possible due to the extreme pressure and temperature that exist within the core of the sun. This extreme pressure and temperature are estimated to be equivalent of 250 billion atmospheres, that is 25.33 trillion kilopascal. Newton per meter square, that is Pascal, is the SI unit of pressure. It is estimated that 250 billion atmosphere pressures are there at the center of the sun, and 15.7 million Kelvin temperature is there in the center of the sun. This high pressure and temperature helps the hydrogen atoms to combine and form a helium molecule. The net results in the fusion of 4 protons, that is hydrogen molecules, into one alpha particle, that is helium particle. 2 protons and 2 neutrons bound together into a particle that is identical to a helium nucleus is the alpha particle. So 4 protons joined together and we got one alpha particle. 2 positrons are released from this process. You can see that thing in this figure. So here proton joined together and gives out the deuteron plus a positron plus a neutrino. So this is then this deuteron and proton joined together gives out helium. Then you got a neutrino particle. Then 2 helium joins together and gives out a helium-3 isotope of helium joins together and gives a helium, then 2 protons. Then again that 2 protons combine together. Like that chain reaction will take place in the core part of the sun, so that sun produces heat energy and light energy. The core is the only part of the sun that produces an appreciable amount of heat energy through fusion reaction. You know, for the existence, for the occurrence of fusion reaction, high temperature and pressure are in need. That high temperature and pressure are provided by the central part of the sun. The rest of the sun is heated by the energy that is transferred from the core through the successive layers, eventually reaching the solar photosphere and escaping into space as sunlight or the kinetic energy of particles. So the heat energy produced by the core part is transferred to the successive layers like chromosphere, photosphere and corona, escaping into space as sunlight or kinetic energy of the particles. The sun releases energy at a mass energy conversion rate of 4.26 million metric tons per second, which produces the equivalent of 3.846 into 10 power 26 watt per second. So such a high energy is produced by sun. This energy is transferred as light and heat into the atmosphere of Earth. You know, power is used to produce the sun. Radiative zone is the zone immediately next to the core, which extends out to about 0.7 solar radii. There is no thermal convection in this radiative layer, but solar material in this layer is hot and dense enough that thermal radiation is all that is needed to transfer the intense heat generated in the core outward. Temperatures drop in this layer, going from approximately 7 million Kelvin closer to the core to 2 million at the boundary with the convective zone. So at the radiative zone, temperature drops down. At the surface of the sun, the temperature drops to about 5700 Kelvin. This temperature is taken as the average temperature of the sun. Actually, this is the surface temperature of the sun. The turbulent convection of this layer of the sun is also what causes an effect that produces magnetic north and south pole all over the surface of the sun. So magnetic field produced or magnetic field existence in the sun is due to the turbulent convection of the radiative zone layer. This is the nuclear reactions produced in the sun. Here one helium and beryllium joins together and produces a carbon atom. This carbon atom is another basic element for the production of energy in the sun. So here you can see that CNO cycle, carbon, nitrogen, oxygen cycle. So here protons join together and produces helium, then helium joins together and produces beryllium, then beryllium and helium joins together, fuses and produces carbon. That carbon is converted into nitrogen by joining with one proton. That nitrogen decays, exhibit a beta decay and converted into carbon 13. That carbon 13 fuses with one hydrogen or proton and gives out a nitrogen. Then that nitrogen without any decay joins with one hydrogen, gives out oxygen. Then this oxygen undergoes a beta decay and produces nitrogen. Nitrogen again joins with hydrogen, then produces carbon. Again carbon joins with hydrogen, produces nitrogen. Like that this carbon, nitrogen, oxygen cycle keep on repeats in the core part of the sun or central part of the sun, which produces high energy that we see in the central part of the sun. High energy in the sense 3.846 into 10 power 26 watt per second of energy at a mass energy conversion rate of 4.26 million metric tons per second. Energy is produced by this carbon, nitrogen, oxygen cycle. Thus energy production in the sun is due to nuclear fusion reaction. In that nuclear fusion reaction, this carbon, nitrogen, oxygen cycle is the prominent part of the sun. This is how the sun, our nearest star, can be learnt. So in this lecture we have learnt the mass of the sun is 2.0 into 10 power 33 gram. Radius of the sun is 7 into 10 power 10 centimeter or 7 into 10 power 5 kilometer. Average density of the sun is 1.4 gram per centimeter cube. Then the center part of the sun is core. Its radius is just about 10% of the full size of the sun. Photosphere, chromosphere and corona are the layers of the sun's atmosphere. Energy production in the sun is due to carbon, nitrogen, oxygen cycle. So like that we have learned things through this lecture. You can refer these websites to learn more about our sun. Thank you.